Welcome back, guys. So this is our second lesson in Unit 5, and we're talking about everyone's favorite topic, slope. Now, slope kind of it does play off of what we did last time with rate of change. Slope is the exact same thing as rate of change, you guys. It just doesn't have a label. So remember last time we did the cost every ounce of oregano. So it was like 50 cents per ounce. So we had like labels on our numbers. We had ounces, dollars, gallons, miles, all that. Slope is exactly that. It just doesn't have the label on it. So it's still talking about the change in y over the change in x. So I'm still talking about how x and y are changing and how they're related to each other as they change. My answer for slope, like rate of change, then should be a fraction. I just don't have to put any like units on the two numbers. My answer is just going to be 2/3 or 1/2, something like that. Okay, so let's kind of like dive right into it. And the setup here is similar to last time as well. You'll have to find the slope between a few different things. So we'll have tables again. We're kind of used to that from last time. This one shouldn't be too bad. Maybe they'll give us 2 points, and then maybe they'll give us a graph. So it's really similar, exactly the same, except I don't have to do the label part, which maybe makes it a little bit easier, and you won't have to explain it either, like in a sentence. So let's start out by finding the slope between 2 points. Now, a related question here. So think about like real life. If the temperature outside was 45 degrees and it's now 58 degrees, what was the change in temperature? Okay, if someone asks you that question, in your head or in your calculator, you'd probably say, all right, well, let me take the current temperature and subtract what it was. To find that change, I would subtract those, and it would be a 13-degree change in temperature. So I'd be finding the difference. I think a lot of you, hopefully all of you, would do that if someone asked you that question. Now, the idea is the same. If you want to find the change or how two things are changing, you subtract them like we just did. So let's say I have two points, two ordered pairs, and you guys know ordered pairs are like x comma y. Since there's 2 of them, they just put like little 1s on the first ordered pair and little 2s on the second ordered pair. If someone asked you what's the change in each coordinate, or like what's the change in the x's, what's the change in the y's, if you're asked that question, how they're changing, then you're just finding the difference. You're just subtracting them. So here's what I'm going to use, and it's a formula. I don't know, I feel like you've seen this before. If you haven't, don't worry about it because we're going to treat it like you have not seen it before. But I'm trying to find the change in the y on top. So just like I was finding the change in the temperature, I took the new temperature and I subtracted the old. So if you're trying to find the change in the y for the ordered pair situation, you're going to take the new y value, which is y2, and you're going to subtract y1. You're going to find the difference between the y's. For the x's on bottom, same thing. You're going to take the new x value and subtract the old, and you're going to find the difference between those. So you can use the idea of making a table like we did yesterday, last time. But realize there's also this formula. If you're asked to find the slope between 2 ordered pairs, it works the exact same way. Okay, the one thing I want to point out about the formula is you have to be consistent if you're going to use this. Okay, notice I did like the new y minus the old one. Then I did the new x minus the old one. So I did the second x and y first, and then I did the first x and y. You can't go y2 minus y1 and then x1 minus x2. Okay, you have to be consistent, otherwise you will get a wrong answer. Okay, so let me show you using the formula. Here's what I would do. If they say, hey, find the slope, or like, how are the y's changing, how are the x's changing, how are they related, and I'm going to use this formula right here. So it's helpful and almost necessary for you to get the labels on there. So you know, well, what is y2? What is x1? So again, ordered pairs are x's and y's. Because there's two, we would call that the first ordered pair, and we would call that the second ordered pair. Okay, so to use my formula, I would do y2, which is 8, minus y1, which is 5. Do that on top. On the bottom, x2 is 9, and x1 is 3. So on top, 8 minus 5, that would just be 3. 9 minus 3 would be 6. Just like yesterday, you should always reduce your answer. I can divide both of those by 3, and that would just give me 1/2. Okay, I'm going to make a note here. Always reduce. That part hasn't changed from rate of change from last time. Now, I do just want to point out, you guys, that like you don't have to use this formula. Last time I taught you to just make a table every time. So look, if you wanted to do this, I'm totally okay with it. If you wanted to just organize this into a table, you could do what we did last time, and you could say, oh, okay, I added 3, I added 6, boom, 3/6. Same thing as 1/2. Okay, you could literally do that exact same thing on every problem. I don't care. It's totally up to you. Okay, so you use whatever works for you. Rate of change and slope are the same thing. Slope just doesn't have labels. Knock yourself out. All right, I'm going to go ahead and do this next one as well, just because there are negatives involved, and I don't want anyone to make a mistake. So I'm going to use the formula. So I'm going to call that x1, y1, x2, y2. On top, I'm going to do y2 minus y1. On bottom, x2 minus x1. Now, the formula, you guys, is subtraction. So when I did 1 minus -3, there's a double negative right there. Be careful. That's kind of why I didn't have you try this one on your own. People will mess that up. You're actually just adding on bottom. So it'd be 4. And on the top here, -8 minus 2, that would be -10. Okay, now I want to reduce that, so I can divide both of them by 2. So that would just give me -5/2. And that would be my slope. You can't reduce any more than that. Okay, so same thing. You could do the table. It's really just totally up to you here. All right. Number 2, I'm not really going to think that hard about how I want to do this problem. It already is a table. So I'm going to do exactly what I did here, what I did last lesson. I want to find the slope. Let's answer these questions first. This asks how many points are actually given, how many ordered pairs. Well, each row is an ordered pair. So there's 1, 2, 3, 4. But realize that you only need 2 to calculate the rate of change of the slope. So you only have to look at 2 of these. Maybe I'll look at the positives. I'm going to be different. Most people would look at the top 2. Nope, not me. Let's just look at these. So y is on the right. I want to figure out how I'm changing over there. Well, it's getting smaller, so I'm subtracting 12 to 6. I would subtract 6. Over here on the left, you're adding 3. And I know slope and rate of change. I do how the y is changing over how the x is changing. And I want to reduce that. So -6/3, that's just -2. I'm going to keep it a fraction, so put the 1 underneath. Okay. So far, so good, hopefully. Now, the next example, and really the last example, is finding the slope of a line given the graph. We kind of did this last time. Again, there's just no labels, and you don't have to watch scales because they probably will always be counting by 1 on here. You just really need to think about like signs. So let's see what I mean by that. And they gave me like two nice points to kind of count the slope between already. You can kind of see them there. They're easier to see on example 2. But before I count the slope, I want you guys to note that in this first graph, when you count the slope, so the slope basically, you guys, is telling me like how steep the line is. That's all this is saying. So you got to think about like how this line is positioned. As you go, and I'm going to count the slope from left to right. So as I go from left to right, the line's going down, or it's like a downhill line kind of thing. When that happens, the slope is negative, because I know that down, that direction on the x and y axis, is a negative direction. So here's how I'm going to count the slope. And again, I'm going to go from the point on the left and count to the point on the right. You guys probably remember, like from middle school, hearing rise over run. That's used when you count slope. So basically, the rise is your top part, your top number. That's how you're moving up and down, the y value. And then the run, that's how you're moving from left to right. That's how the x is changing. So when I start at this point, to get down here, I go down 2, and I go right 1, 2, 3. And again, you have to think if you went in a positive or a negative direction. So when I go down, down is a negative direction, so it's actually -2. That's my top number on my slope. And then I went right 3, so the bottom number is 3, right's a positive direction. I can't reduce that, that's my slope. Okay, so again, I'm still just showing like how the x is changing and how the y is changing. X or y is up and down, so that's kind of why I did the -2 on top. If you remember rise over run, you should be good there. Okay, for example 2, as you go from left to right, so they bolded 3 points. Maybe I just use these 2. As you go from left to right, the line is going up. Up is the positive direction, so the slope would be positive on this one. Okay, I want you guys to see if you can count the slope on this one. So it's like up how many, over how many, and you just make a fraction out of it. Now, there's 2 special cases, and they're vertical and horizontal lines here at the bottom. I'm going to show you a video in class next time to kind of, it's really stupid. Honestly, it's like the dumbest video ever, but I feel like the dumb things sometimes help you remember certain things like this. So they might help you with vertical and horizontal lines as well. But sometimes you might be asked, hey, what's the slope of this line? Or what's the slope of this green line? Now, again, up here, if it's going like downhill, it's a negative slope. If it's going uphill, it's a positive slope. These 2 special cases aren't doing either of that. But I could still count like rise over run like I did here. So maybe on like the vertical or the horizontal line here, if I just found 2 points, I could figure out rise over run. Here's what I would do. So to go from left to right, I wouldn't go up or down at all. So the rise would be 0. I would just run, I'd go right 2. 0 divided by anything, you guys, is just 0. So if you're given a horizontal line, like this first case, the slope is always 0. And there's a couple easy ways to remember that. So it's kind of like cross-country skiing. Think skiing, that helps with slope. Cross-country skiing, which is like so boring, no offense to anyone that likes it. I think it's so boring though. When you're just going on a flat surface, there are 0 slopes. You just go straight. Also, you can make a Z for 0 out of this horizontal line, so maybe that's a little bit easier to remember. For this one, a vertical line, again, I could count rise over run, so maybe I found like 2 points. So to go from this one to this one, I do have to go up and down. I would go down 1. I wouldn't want to go left or right. Okay, this is not 0. If you put this into your calculator, oh, struggling. Seriously struggling. If you put this into your calculator, it says error. You can't divide by 0. So like this is not a thing. There's a special name for this, and think skiing again, you guys. This would be you just like jumping off of a cliff. It's very sad. Please don't do that. Okay, there is no such thing as jumping off of a cliff in skiing, hopefully, and you can't divide by 0. So this, if you have a vertical line, the slope of this, we say undefined. And I hope you've heard that before. I'm not sure, you guys can maybe tell me tomorrow, but any vertical line has an undefined slope. And a way that you can kind of remember that is just like with making a Z out of the horizontal line, you can make a U, it's kind of forced. You can make a U out of that and say undefined slope. Again, I'll show you a video tomorrow that will probably help keep all that straight.